Jai Hind everyone. Again, I am with the new video which is called as a glycogenolysis. This is a continuation of the series of the videos. If you didn't watch the earlier videos, you can watch here by you can see the links here on the above right side corner. You can tap and you can watch the earlier videos. So glycogenolysis is the important in terms of the body metabolism, in terms of the examinations also. So glycogen. Just now we seen how glycogen will form. Now we will see how glycogen will be breakdown. So there will be this type of. So it looks like this. There is a chain of the glucose. Okay. So two things you can see here. The it is a alpha 1 for glycosidic bond. This is alpha 1 for. This is alpha 1 for glycosidic bond, and this is alpha 1 6 glycosidic bond. So where we can start the hydrolysis, not exactly hydrolysis, from where we can start the break this glucose. So it depends only on the enzyme which is going to break it. So we have the major enzyme, the glycogen phosphorylase. Okay, so it is like a something like this. It is looks like this something. So glycogen phosphorylase can break, can cut only the, you can cut the non-reducing side, where it can cut the non-reducing. So what do you mean by non-reducing? So if I am saying non-reducing, so non-reducing means where the free aldehyde or the ketone groups are available to not available. So that is called as non-reducing. So here this glycogen phosphorylase will cut this side. Here for activity of this it required exact something called, I'm going to make it like a specs. So that is called it required some take big hands. Why not? You can make a hand. So this is what? This is something called pyridoxine phosphate. Pyridoxal phosphate. So what it will do? The glycogen phosphate is the it required the pyridoxal phosphate, which will activate this inorganic phosphate to break over this alpha glycosidic bond. So it will break it here. Okay, it will break this. So finally, what you will get, the pyridoxal phosphate helping the glycogen phosphorylase to break the alpha 1,4 glycosidic bond. So you can start breaking anywhere. Okay, it can start breaking anywhere, and you will find here, what you will find here, the chains which is drawn here, it will become shorter. It will become shorter. Okay, so until the fourth region, until where? Until the fourth region, it will break. Fourth residue of the glycosidic bond. Until the fourth residue of the glycosidic bond, it will break here. No. So until this fourth region it will break here, but important thing is that this three residue will transferred now by the another enzyme, copy and then paste. So these three residues will be transferred over here. Okay, again these three residues are transferred here. So I am going to make it with a different color. Green will be okay. Color doesn't change. Wait. So the another enzyme which helps these three residues to pass over these three residues to come here, to transfer here by the enzyme which is called the debranching enzyme. Okay, what it is called? Debranching enzyme of glucan transferase. Okay, you can see. I can write it here. Glucan transferase. Transferase. This is debranching. Debranching enzyme. So it have two roles. It will transfer the three residue of the linear chains to the another linear chain. Okay, it doesn't transfer the alpha 1,6 glycosidic bond. So I am going to erase it now. I will erase like this. So it is disappeared. Okay, now it is not there. So the remaining will be what? This will be remaining. Now we have to break this as well. We have to break this glycosidic bond also. What we have to break? We have to break this glycosidic bond also. Now this glycosidic bond will be broken down by what? This glycosidic bond is broken down wrong. So this glycosidic bond will be broken by the same enzyme, the debranching enzyme. Okay, that is broken by this debranching enzyme, which is called alpha 1,6 glucosidase. And finally you will get the glucose. Finally what you will get? You will get the glucose. So if maybe somebody will have the doubt, if you are transferring like this the remaining residue, the chain will be again become long and long and long. So ultimately we are not breaking the glucose, we are not breaking the glycogen into the glucose residue, but we are making a long chain. So the important thing is that the glycogen phosphorylase will be always there. Okay, this glycogen phosphorylase will be always there. It is not disappearing. So it will, if it is present, then it will be breaking again. So this again glycogen phosphorylase will break all this residues in alpha 1,4 direction. Okay, now this will be broken down and you will get the, then finally you will get the glucose. Okay, what you will get? You will get the glucose. So this is what about the glucogenolysis. Hope so you understand. Now the important thing is that this pyridoxal phosphate is what? This pyridoxal phosphate is nothing. Pyridoxal phosphate. From where it is coming? This pyridoxal. It is coming from the pyridoxine. Okay. What is pyridoxine? So pyridoxine is the vitamin B6. So what is important about the vitamin B6? If you are not taking the vitamin B6, then there will be there may be the problem in the carbohydrate metabolisms. Okay, so you will not get the proper glucose, or your body will become very thin and you may be become lethargic and kind of things. Okay, so you have to get this vitamin B6. So there are the three important sources of the vitamin B6. So what are the source? Anybody can guess? So first is the chickpea. Okay, second is the liver of the any cat, like goat or other organisms. Chickpea, and then salmon fish or the other fishes. Okay, so you can get it from there. Hope you enjoyed this video, and this information is important. So get it proper diet, so your your metabolism will be appropriate. So thanks for watching till now. We'll meet in another video again. Jai Hind.